In this section, we're going to learn how to name and draw a few of the covalent structures. So when we're naming a covalent molecule, it's somewhat similar to the ionics, but there's a couple of differences that I want to point out. So if we're going to name NO2 and N2O4, the first thing we're going to do is we're going to call the nonmetal, the first one, by its element name, okay? And the second one will use the suffix IDE, which should sound kind of similar. So the N is nitrogen, so you'd call that nitrogen. And then oxygen is going to be named oxide. Then the difference, though, in covalent is because you could have multiples of N's and O's in a compound, in a molecular compound like you see for these two, we do have to say how many of each thing we have. So this could be considered nitrogen oxide if it was similar to the ionics. However, you can actually have this exist as N2 and O4 with two N's and four O's, or you could have NO2 with one N and O2. So you do not reduce in when you're naming covalents because they can exist in those states. So in the case of the covalent molecules, you're going to add prefixes to show the number of atoms in each one. And if it's just one, you use the prefix mono, and I'm going to show you the table with all the prefixes here in just a second. But mono is not used if it's the first one. So like if you only have one of the first of the two nonmetals, you don't say mono and then the name. You only use mono for the second one, okay? And I'm going to show you what I'm talking about in a minute, okay? All right, so in the case of NO2, we only have one nitrogen, and so when it's the first of the atoms, you do not put the prefix on there. So you don't say mono nitrogen, you just say nitrogen. It's kind of like we don't put the one as a subscript when we only have one in the formula. So it would just be nitrogen. And then since it's a covalent, how do we know it's covalent? Because there's not a metal in it. If there's a metal anywhere in the formula, then that first place is where it's going to be, then we would know that's an ionic, okay? And we wouldn't use these prefixes, but we do use the prefixes in a covalent. And so I'm going to have to say how many of those oxygens I have since it's a covalent. And so it's nitrogen dioxide, and so di is for two. But in the case of this one, N2O4, since it does have two in the first one, I'm going to have to call it dinitrogen. And then for four oxygens, it's going to be tetroxide. Notice that I don't say tetraoxide, even though that is that. It's just too hard to say tetraoxide. So we drop that A and we just say tetroxide. So dinitrogen tetroxide is that second one. To me, these are easier than the ionics because, I don't know, they just make a little more sense to me. All right, so this first one we're going to name is Ni3, okay? So we know that that is nitrogen. And then how many iodines do we have? We look over here, there's three. So it's going to be nitrogen triiodide. Nitrogen triiodide. So you don't drop the I's, only the when it's going to be the oxide form. All right. PCl5 is going to be, and you can, if you need to look these up, phosphorus is what P is. And 5 is penta, so pentachloride. And then I've got phosphorus on this one too, but how many do I have? 4. So this is going to be tetra phosphorus, deca sulfide. See, I just think those are easier. All right, and then if I'm going to write the formula for it, it's phosphorus tribromide. So it's going to be PBr, and tri is 3. So it's PBr3. Dinitrogen pentoxide, that's an N and an O, right? I've got 2 nitrogens and 5 oxygens, so it's N2O5. See what I mean? So I think those are a little bit easier than the ionics.